All right, let's get right into it. Today, we're dissecting a moment that was supposed to be a massive display of national pride, but in just a few seconds, it turned into a global disaster. We're talking about the crash of India's Tejas fighter jet. So, what exactly went wrong on the world stage? Let's find out. So, picture this, the Dubai Air Show. It's one of the biggest, most prestigious aviation events on the planet. And right there, front and center, is India's Tejas fighter jet. This isn't just any plane. It's a 4.5 generation multi-role combat aircraft, really designed to be the ultimate symbol of India's aerospace power and its tech ambitions. You've got thousands of people watching from the ground, millions more glued to their screens all over the world. The pilot is pushing the jet through a really demanding low-altitude maneuver, and then the unthinkable happens. The flight goes horribly wrong. The jet just spirals out of control and crashes. In an instant, that moment of pride becomes a public disaster for everyone to see. And that, of course, raises the one huge question. Why did the Tejas crash? Was this just a tragic freak accident, a one-off event? Or was this the inevitable outcome of much deeper systemic problems that have been haunting this program for decades? To even begin to answer that, we have to look way beyond just the final tragic moments of that flight. Our investigation really starts with the long and pretty troubled history of the Tejas program itself. We're talking about 40 years of compromise. So get this, the Tejas program kicked off way back in 1985, but the very first jet didn't actually enter service with the Indian Air Force until 2016. That is a development cycle of almost 40 years. I mean, that right there is a huge red flag. It points to a program that was just stuck in this endless loop of changing requirements, technology gaps, and constant redesigns. And, those long delays, they had very real-world consequences. The manufacturer, Hindustan Aeronautics Limited, has had this long history of struggling with quality control. We've seen consistent reports of things like persistent oil and fuel leaks, panels that don't line up correctly, weird vibrations, and even issues with immature flight control software. All of this suggests that this jet wasn't built on a foundation of pure engineering, but on a series of painful compromises. And this wasn't some big secret. The Indian Air Force itself had been raising alarms for years. A former Air Force chief, V.R. Chowdhury, pretty much summed it all up when he reportedly said, "At this point, I have no confidence." You see, for decades, the Air Force felt like they were asking for a top-tier fighter jet, but what they were getting was a political project, a symbol of Made in India that was being pushed forward, whether it was technically ready or not. But the aircraft's troubled history is only one piece of this puzzle. Now, our investigation has to shift from the machine itself to the human element, the pilot in the cockpit, and the extreme physical forces that were at play. So the pilot was in the middle of a maneuver that put him under something called negative G-force. Now, unlike positive Gs, which everyone's heard of, the ones that push blood down towards your feet, negative Gs do the exact opposite. They violently force blood up into your head, and the human body is it's not built to handle that. It makes it way more dangerous than the G-forces pilots usually train to endure. Okay, let's break this down a bit. Under positive G-force, blood rushes down. That's why pilots wear those special G-suits that squeeze their legs to keep blood up in their brain and prevent a blackout. Simple enough. But with negative G-force, blood rushes up. There's no suit for that. There's no mechanical defense, no natural way for the body to relieve that intense pressure building in the brain. Instead of a blackout, the pilot faces the risk of a red out. And here is where it gets incredibly dangerous. When a pilot is pulling those negative Gs, their body tries to protect the brain. It does this by opening up, or dilating, the blood vessels in the lower body trying to pull blood away from the head. But what do you think happens the split second that maneuver ends and the pilot rolls upright? All that blood that was pooled in the head suddenly drains away, rushing down into this now wide-open vascular system. This catastrophic drop in blood supply to the brain can cause what's known as a G-force-induced loss of consciousness, or G-LOC. Okay, so we have a machine with a history of mechanical issues, and a pilot who was under extreme physiological stress. But before we can draw any conclusions, we have to look at the aircraft itself and rule out some of the most obvious culprits. Right, let's look at the two most likely mechanical suspects. First up, the engine. The Tejas uses a General Electric F404. It's an incredibly reliable engine, known for its stable airflow, and it was clearly producing enough thrust to recover, assuming the pilot had enough altitude. So an engine failure is highly, highly unlikely. What about the fly-by-wire system? That's the jet's digital brain, basically. But it's built with so many redundancies and failsafes that a sudden, complete failure is also just really improbable. So, with a major mechanical failure looking less and less likely, all the evidence starts to point very strongly in one direction. It's time to bring all the pieces of our investigation together and look at the G-log hypothesis. Based on the analysis from our source, the most likely cause of this entire tragedy was G-force-induced loss of consciousness. It seems it wasn't a case of the plane failing the pilot, it was that the extreme forces of the maneuver literally overwhelmed the pilot's body. And if you look at the video evidence, it aligns almost perfectly with this theory. The crash happens right after the pilot transitions from negative to positive Gs. That's the single most dangerous moment for G-lock to occur. The footage shows the jet's nose just dropping sharply, but you see no noticeable attempt from the pilot to recover. This suggests a pilot who isn't unconscious, but is likely incapacitated, awake but with a total loss of spatial awareness. And the ejection? It happens extremely late, which points to a delayed, almost automated response, not a proactive, conscious decision. This very public tragedy has, as you can imagine, created massive fallout. It's basically pushed this 40-year-old program to a critical and very public crossroads. And the stakes here are just enormous. This isn't just about one lost aircraft. India had incredibly ambitious plans to export the Tejas. We're talking nations from Malaysia and Argentina, all the way to even the United States being considered potential buyers. This one crash has severely damaged the Tejas' reputation on the international stage, putting all of those multi-billion-dollar ambitions in serious jeopardy. Which leaves us all with this final question. Tragedies can often leave behind powerful lessons, but only if those lessons are actually learned. After 40 years of compromises, the world is now watching to see if India can use this devastating moment to finally address the deep-rooted issues in the Tejas program, or if politics will, once again, triumph over engineering. The entire future of the Tejas really hangs in the balance.